Going to be looking at parallel forces and looking at the resultant of those forces, looking at what those forces can do to things, um, and then being able to calculate some different forces. Now we've got 5 different things here to do. So obviously, if you've got 2 plus 20, we know what that's going to be. It's going to be 22. But we can represent these. If these are forces, so this is 2 newtons and 20 newtons, and we can describe these with our arrows. And then a scale drawing, so we normally have plus going towards the right hand side. So what about if you had 34 plus 678? Well, again, if we had our force arrow showing a 34 Newton force, and then that would mean that our 678 Newton force would be like that. And that would be an answer of what, 712 newtons, wouldn't it? Okay, so what about if you had 34 minus 34? Well, obviously that's going to be 0. And if we were to draw a diagram of that, we could represent an arrow of 34 newtons like that, positive, maybe to the right-hand side. Negative, we would just show the same sized arrow, because it's 34, the magnitude is the same, the size is the same, but it's going in the opposite direction. That's what basically this negative sign means. So when we're looking at forces, we normally represent positive to the right and negative to the left. And so here we've got positive 34, negative 34, and those two would just cancel each other out, and we would have a force of nothing. So our resultant force in this case would be nothing. How about this one? If we had a force of minus 4, so it'd be minus 8, wouldn't it? And so that's basically going to be a resultant force of 8 newtons to the left. And how about this one? You wouldn't get anything like this, I don't think, but minus 12 minus 13. As you know, minus would just mean positive. So we would have a force of 1 newton to the right. Okay, so let's have a look at an example of forces that might be in parallel. So here, let's say this blue box here is some water, and here we've got something floating in the water. So we would have forces on this, wouldn't we? So we'd have 2 forces, and at the moment this boat, this rectangle, which we're calling a boat, is unladen. Basically, it's got nothing in it, nothing weighing it down. So the 2 forces that it would have would be weight down, because of the force of gravity, and there'd also be a force pushing up, which we would call the upthrust. And you can see that this force here would equal this force here, and so this would mean that this boat would float. If we put 100 grams in, then the weight would increase, and you can see that it would float lower down in the water, but the weight pulling down would still be equal to the upthrust, because it would still be floating, it would just be lower down in the water. If we have 200 grams in, we'd have a larger force, a larger weight down. You can see these arrows are getting greater. The upthrust would equal it because it's floating. So the upthrust would equal it. So each time here, the resultant force is going to be 0. Here, we would have a tiny little upthrust, maybe because of the water that's being displaced by the boat, but most of it would be the reaction force from the floor of the container pushing up, and that would equal the weight and the gravity, because again, it's stationary, the resultant force is 0. Okay, so here's an example of using forces. So, in this presentation we will be considering what happens when 2 forces acting on an object. We already know that. This is a common question in examinations. So I've said here answer the questions that come up on the whiteboards, but whatever you've got to hand, just have a think about what the answer to these might be. So if you consider this car, we've got force from the engine towards the right, bigger than the force of the air resistance towards the left. So the force is bigger than the air resistance. What's it going to be doing? Have a little think. Yes, so this force is going to be making, the resultant is going to be making that car accelerate. And so this is one of the things that can happen when we've got a resultant force on an object. It can cause that object to accelerate. Wow, special effects. How about this next one? So it's now going faster. So the force on the engine is still bigger than the air resistance. But you can see that the air resistance has got bigger. What's it going to be doing now, do you think? Okay, again, it's going to be accelerating. Just probably not accelerating quite as much because the resultant force isn't going to be quite as much. So it's going to be accelerating. No expense spared. And then if the air resistance is now equal to the forward force, now it's going its top speed, what's it going to be doing now? So the resultant force is now going to be nothing because the force to the right is going to equal the force to the left. So is it going to be accelerating? No. Is it going to be decelerating? No. It's going to be moving at a steady speed. So when we've got a resultant force of nothing, it could mean that the object is moving at a steady speed, like in this example here. Right, now we've got the brakes being applied, so we've got the air resistance and we've got friction now, which is greater here than the forward force from the engine. So the resultant force, is that going to be to the right or to the left? Well, it's going to be backwards, isn't it? I don't know why it hasn't got anything there, but yeah, it's going to be backwards. So the resultant force is going to be backwards. So what's going to happen to this car? So if the resultant force is backwards, it's not going to necessarily mean that it's going to go backwards, but it's going to slow down, isn't it? It's going to decelerate. Okay, so this is a lesser aerodynamic car, as you can see. Compared to the red car, what do you think its top speed will be? So lower, you can see that the force there, because of the, it's going to have a greater air resistance, and so because of that, it's going to have a lower top speed. Right, so we had two forces in all of these. Now we've got some coplanar forces. That basically means we've got forces in one direction here, and we've got other forces here. They're all on the same plane, literally on a plane here. And so let's see what we think is going to be happening. So describe what the plane is going to be doing. So if we cancel out all these forces, this lift is going to equal the weight, and the thrust is going to equal the drag. So does not mean that because the resultant force is going to be zero, the plane is going to drop out of the sky, but it's going to mean that it's going to be going at a constant speed, and it's not going to be moving up, and it's not going to be moving down, it's going to be going at a constant height as well. Now what happens if the thrust gets larger, but all the other forces stay the same? So the lift and the weight cancel each other out, the resultant force of those is going to be zero, but the thrust is greater than the drag, so that means it's going to be accelerating, but still at a constant height. Now, what happens if the lift is smaller than the weight, but the thrust and the drag are the same? Then you can see that those two there would cancel each other out. The resultant force would be down, it would start to accelerate downwards. Right, so we've had a look at how different forces act, describe the forces, and hopefully in some practice questions you'll be able to look at that. Okay, that's Mr. Baker finishing there. Thank you very much.